Now we'll be looking at the forces that influence the winds. Before we go into that, the higher water level, if you are looking at the picture, the left, the higher water level creates higher fluid pressure at the bottom of tank A and a net force directed towards the lower fluid pressure at the bottom of tank B. This net force causes water to move from high pressure towards the low pressure. That's the mechanism that happens into the air too. If you are looking at the picture of the right, figure shows the region of high pressure on the map left side, sorry, right side, lower pressure on the right. The isobar shows how the horizontal pressure is changing. If we compute the amount of pressure changes that occurs over a given distance, we have the pressure gradient that we can express that in equation. Pressure gradient is equal to the difference in pressure divided by the distance. If we let the symbol of delta means the a change in, we can simplify the expression of this pressure that Pg, pressure gradient, we would say always the pressure gradient is equal to delta P divided by D, where delta P is the pressure difference between two places of the horizontal distance. And if we are talking about the picture of the right, we have all the isobar lines over here. So each of the isobar lines is difference in 4 millibar of pressure. So 1024, 1020. So each of the lines are difference in 4 millibar. Okay. Suppose that pressure in this picture we have changed, the isobar become closely together. This condition would produce a rapid change in pressure over a relatively short distance, or what is we call it the steep or strong pressure gradient. The bottom line is there that if we see in a pressure map or weather map, the isobar lines are closely spaced, we can assume that there is a strong pressure gradient, which means we have a chance that wind will blow very strongly from high pressure to the lower pressure. If we see in the weather map, the isobar lines are widely spaced, so we can see there is a gentle slope, gentle or weak pressure gradient over there. So when the differences in horizontal air pressure exist, there is a net force acting on the air. This force we will call pressure gradient force, PGF. So this pressure gradient force is directed from higher towards to the lower pressure at right angle to the isobar line. The magnitude of this force is directly related to the pressure gradient that I just told. The steep pressure gradient corresponds to the strong pressure gradient force and vice versa. So the figure shows that the relationship between pressure gradient and the pressure gradient force. So pressure gradient force is the force that causes the wind to blow. Because of this effect, I already told you that closely spaced isobar on a weather map indicate a steep pressure gradient, strong force, and high wind. On the other hand, widely or sparsely spaced isobar indicates gentle pressure gradient, weak force, and light wind. If the pressure gradient force were to the only force acting upon the air, we would always find the wind blowing directly from higher towards the lower pressure. But the situation is a little bit different in the real world. So in the global wind system, wind blow from high pressure to lower pressure but due to the rotation and one force we call Coriolis effect, that actually our wind direction veer in right in the northern hemisphere and left in the southern hemisphere. And the next slide we'll be talking about that.